Hi children, I'm teacher Geeta. I'm going to give an explanation about this grade 11 physics topic, free and damped oscillation. This is the last topic of our oscillation, that is oscillation unit. What do you mean by free oscillations? Already we studied that one. What is free oscillations? An object which moves to and fro is said to be oscillate. Each to and fro movement complete one cycle of oscillation. This free movement, that's called free oscillation. When a body oscillates with its own natural frequency and under no external influence other than the impulse that initiated the motion. This motion described as free oscillation. An example is a simple pendulum is an example of a body undergoing free oscillation. Here see, a free oscillating object oscillates with a constant amplitude. The amplitude is constant. So, the total of the potential and kinetic energy object will remain constant. Potential energy plus kinetic energy is constant. But this occurs when there is no frictional force acting on the object such as air resistance. But no external influence is happening. That is called a free oscillation. What do you mean by damped oscillation? But damping means when energy is removed from a system undergoing oscillations. It is called damping. It reduces the amplitude over time. But this happens due to the frictional force like air resistance. But damped oscillation, here is one example of damped oscillation, and the motion occurs when an object is attached to a spring and submerged in a viscous fluid or liquid. And here it is damped oscillations. A real world system have some dissipative forces that decreases the amplitude. The decrease in amplitude is called damping and the motion is called damped oscillation. So, how is energy damping happens? The energy removed from the system that undergo oscillation. If it is undergoing oscillation, if the energy is removing, then we can say that it's called damping. But here it is the graph showing light damping. See the amplitude of the wave. Here heavy damping, this one is showing critical damping, the graph is showing like this. And forced oscillation and resonance. For forced oscillation, when a system is made to oscillate by an external force, we are giving a force, that is forced oscillation. It is said to be undergoing forced oscillation. An example of forced oscillation is pushing a moving pendulum in the opposite direction to turn back repeatedly. A forced oscillating system is driven by a periodic force, playing a swing. This is an example of forced oscillation. And each time you push, the swing goes higher and higher. That is the power of resonance. For forced oscillation resonance, the sharpness, here see the graph showing the sharpness of the resonant peak depends on the damping. If the damping is small, there is quite sharp graph. You can see that one. If the damping is larger, it is less sharp. Like damping, resonance can be wanted or unwanted. Resonance, sometimes it is useful, sometimes it is harmful. See, musical instruments and TV, radio receive depend on this. This is the useful. Resonance is useful in musical instruments and TV, radio receivers. For resonance examples and uses. What is resonance? When an object is driven at its natural frequency, the object vibrates with the maximum possible amplitude. This phenomenon is called resonance. But this is because at that frequency the energy transferred to the system is most efficient. When an object is driven at its natural frequency, then the object vibrates with its maximum possible amplitude. But here this time the energy transferred to the system is most efficient. This phenomenon is called resonance. An example of resonance is a child on a swing gets pushed by his father at a frequency close to its natural frequency to increase the amplitude of oscillation. Uses of damping. See, example of resonance can be seen in earthquakes when the driving frequencies become equal to the natural frequency of the building, causing the building to absorb large amount of energy and oscillate in a large amplitude, resulting into collapse. So when earthquake happens, there is a resonance, there is a vibration is happening. The actual frequency of the building is balanced with that one, it will collapse, and therefore steel rods are used to build buildings. As steel is a ductile material, it will also absorb energy and get plastically deformed. But since this won't release the energy back to the building, the energy is removed from the system and the building is safe. Okay, so this time the damping is useful, or the resonance is uses. And then mass on a spring at resonance. These are the examples of resonance. Mass on a spring at resonance. Swinging your legs in a swing. Breaking a wine glass using sound. If you are making a high sound in front of a wine glass in front of your mouth and you are making a high sound, after some time using that vibration, that glass break down. That is also an example of resonance. A single rod caused by forced vibration. And a tuning fork exciting a guitar string, a truck driving on a rough road. All these are examples of resonance. I think you understand resonance. When an object is driven at its natural frequency, the object vibrates with maximum possible amplitude. That phenomenon is called resonance. Now, resonance is useful or harmful. A useful resonance. The resonance can be useful when a radio is turned by causing the quartz crystal to resonate at a particular frequency. And wind instruments rely on the resonance of a vibrating air column to make an audible sound. And because of the sharp strike on the frequency response curve, other frequencies are cancelled out and not heard. So in radio, TV, transmission, this resonance is useful, and musical instruments, the resonance is useful, and it may cause violent swaying motion and even catastrophic failure in improperly constructed structures, including building and bridges and airplanes. But this is a phenomenon known as resonance disaster. But this time the resonance is harmful. But this way it is happening, the improperly constructed structures that will damage using this earthquake or something happened, but that is called resonance disaster. Avoiding resonance disaster in a major concern in every building, tower and building construction project. Okay, here it is one video about resonance, and watch this one, and after watching this video also you can understand well. Watch the video well.